again, reverse the video so it doesn't have to be read backwards. Shame. Looks like it won't let us do that automatically here.
Oh. Thank you.
Okay. All right, note to self, set each video to reverse left to right for transcoding so that the board is not unintelligible. There's always something else. All right, cool.
Excuse me, word walk hard?
Word walkthrough. This is a shortened form of,
Okay.
because English is a Germanic language, we pick up spelling of words in weird ways. All right. So this projector is back online again. On it. Okay, let's see if that works here. Okie doke. Let's get started here. It's just at the top of the hour. How are things going? Let's check in real quickly with everybody. Lab notebooks going okay? Page counts going up on those? Awesome. All right. Don't just nod and look pretty at me. Use those things, right? If you are not in that habit yet, jump into it. All right. Secure automated offsite backups? Yes, no, maybe? All right.
Probably.
You're on thin ice. You are inviting disaster. Murphy's Law is not that everything that can go wrong will go wrong. It's simply that everything that can happen will happen. And we just pay a lot of attention to with our negative selection bias on the sort of steaming hot catastrophes and disasters when a hard drive goes up in smoke or somebody's laptop gets stolen or whatever it is. So if that is not automatically backing up your stuff to the cloud or to a hard drive that you are in the habit of plugging into every day, then go ahead and spend 20 minutes to set that up. I believe everybody has a terabyte of space with OneDrive through Microsoft here as a affiliate of the university. So if nothing else, go ahead and use that. Cool. Progress or questions on proposal writing? We're still in that sort of longer phase of just bulleting out one idea at a time, one at a time. Some folks like to do this sort of catch can as an idea pops into your head throughout the day. Do that. Other folks benefit from a very specific time of day. We talked about when you're at higher productivity and focus versus lower and being okay with that. And carve out some of that high productivity time for this specifically, scheduling it out and protecting that time from external distractions so that you can do the deep thinking work, as it's called, of writing your thesis proposal. So, going okay on adding bulleted stuff? We talked a little bit last week about how to do literature searches, how to evaluate a single piece of literature to put in or not put in or anything like that. Any questions about the outlining process? Yeah.
It's not so much the outlining, it's more the content.
Sure. Okay.
I find myself wanting to put extra information, like background information.
Mm-hmm.
And I don't know if it's too much.
Okay. That's all right. So to the extent that you have a specific, more or less finalized first, second, third, fourth, fifth draft of your research question, that is your acid test for, is this piece of information useful enough for this specific narrative to get me to the research question or to answer the research question? Everything hangs on that, like we've been saying from, I don't know, second or third class session, whenever it was. So that's the first answer to how do I know when I've got enough? It's okay. Like generally speaking, you do start your literature review and search before having that question. You kind of have to, right? How can you have a well-informed research question without reading a whole bunch of previous research, right? So it's natural in that process of kind of refining that research question and coming to one that is specific. So it's narrow and can exclude a bunch of other stuff, and its coverage complete within that specificity. That is, all of the area that you need to know about, cover, include, cite in your previous research literature review section. You know enough to fill in all of that narrowed space, right? So exclude everything else, include everything within that small sense. Everything is a big word. So let's remind ourselves of that idea of saturation to understand how much is enough within that very narrow chunk or space that you are filling in with some real detail from previous research, having tossed away, ignored everything else. So just real quickly as a review, the idea of saturation is when you are reading your very first research article that you think might possibly be in your dissertation or your thesis. That's probably going to, assuming you haven't done any prior stuff that leads into it, like 100% of that is going to be new and potentially interesting and potentially useful. By the time you've read your 50th article, having done forward and backward citation searches to find the next 50 articles, not 100% of that is going to be new to you, right? So if you're reading a paper that, a useful paper cited, a backward citation search, some of what the newer paper mentioned is what this paper is about. That's why they cited it. So you already know going into this older paper some chunk of whatever the most important chunk out of this older study was. Now you're reading everything else about that older study and deciding for yourself, okay, you know, a third of this is really interesting and what that newer study cited out of this, and that's useful for me. The other 2/3 of it, interesting, but doesn't speak directly to my situation. Maybe the newer, more specific study does. So, 50 studies in, 50 journal articles in, you're down to a third new information. Maybe 10 more studies that you find later, you're down to like 5% of that paper is interesting and new and useful. So when you get down into like single digits of new and useful and worthwhile stuff to mine out of a paper to figure out how to fold that into your literature review or fold into your methods section, typically we cite a bunch of methods papers there. You're never going to get down to zero, but it's a diminishing returns kind of a thing, right? For your first couple of papers, everything out of that paper was potentially useful. By the time you're sort of at the tail end of your literature review search process, single digits, right? That's a lot of effort for single digit percentage worth of payoff out of that same amount of effort from the first paper, which gave you 100% payoff, okay? So that's called saturation, where you've basically saturated the field of inquiry with your search, and you're not finding a whole bunch of new stuff per additional unit of invested effort and time and focus, okay? So when you're starting to butt up against saturation, it's an asymptotic approach. You never quite hit 100%, but out towards infinity papers read is pretty close to 100% saturated. You can feel pretty comfortable about, okay, I've got enough. And so I'm not putting specific numbers on that because that number is going to be different for every project, even in the same field. Sometimes it's 30 or 40 citations because it's a super narrow focused research question. And sometimes, as with one of my grad students, Rebecca, you know, she's got well over 100 citations in her very long and detailed literature review because it's a huge research question. And she wants to do right by that. And honestly, her literature review is probably going to become a journal article in its own right because there's so much work that's gone into that roundup paper. So it's not wasted effort. But also, you know, part of the coaching with that project has been, okay, we're going to cast a big net, and it's going to be a lot of work to pull in all of those more than 100 journal articles and citations into this piece and to organize them in particular. But, you know, when you are starting to feel like, man, I am working so much for this much additional progress, stop, right? Perfect is the enemy of good enough. And science communication, especially for you guys in short 2, 3, 4 year timelines, you have to get to good enough. Now, good enough is going to be pretty darn good, right? You're writing professional level stuff here. We're learning to, but it's never going to be hermetically coverage complete every last thing you're done forever because the fields are continuously evolving. So you do your best, get to that point of saturation, and then work on the rest of it, you know? Does that answer the question? Okay, that was a lot of words. Did I obscure the answer in too much talk?
Kinda.
Okay. Read till you're not finding anything cool anymore, then stop and do everything else. It's good?
Yeah,
Good.
makes sense.
Sounds good. All right. Cool. With that, are there any questions about sort of the technical skills of Microsoft Word? We spent some time last week talking about how do I do X, Y, or Z with field codes or auto captioning, auto table of contents, stuff like that. Is that all going okay? All right, cool. If you do have any questions about that, let's cover those together in class. Whatever you're wondering, somebody else is probably low-key wondering as well. Okay, or maybe they don't even realize they're wondering, but they could benefit from your question. So if we don't have any of those, we'll move on to principles of research, but don't be shy kind of throughout the semester to ask those questions. Even if it's a repeat question, not a big deal, of course, right? Again, somebody else is probably wondering. All right, so let's get into the PowerPoint. This is not really a capture notes for the sake of quizzes and tests. This is all entirely for your information. So if you've seen any of this stuff before, just kind of rest your pencil, rest your typing fingers. You can even rest your eyes. I won't be offended. But if this is new stuff, you know, take some notes. Aid your memory formation and your comprehension process by doing the kinesthetics of the recording. All right, so we've already talked about today's pro tip. Put it into the university's final thesis template. It's easier to start with that than wrangle it into that when it's 20, 30 pages long. So that is one thing to just sort of keep in mind for now. Okay, so what you and I are doing as researchers is servicing the apparatus of knowledge creation. We are cogs in a big machine. And this is a fundamental shift in a way of knowing for human beings versus the last couple thousand years. So earlier societies, back in Ur, for example, ancient Mesopotamia, there was a very cyclical understanding of the nature of time. That is, if we can survive through this year's flood season, then we can do our planting season and grow our crops through the next winter and harvest our crops to not starve through the next winter season so that we can do it all again. Very cyclical understanding of time. With certain major shifts in dominant world religions, for example, we've by and large, at least in Western society, shifted to a very linear and forward-moving sense of time. We're going to use the keyword progress for that. So if we are If we only know as much as we knew at this time last year, then we've lost time, or we've wasted progress, or we've wasted the opportunity for progress. So we want to understand this is a relatively new way of shopping around for the value of ideas, for the value of knowledge creation. But it's proved to be pretty effective in some ways, right? We have things like cell phones and a germ theory that invites us to treat our drinking water so that it is safe. Progress in those areas instead of just going back to the well between now and the heat death of the universe. Okay, so research is simply knowledge creation, and this is one of two ways, going from theory through research methods, data collection, analysis, and inference building, to uncover what we call fact and data and information and capital T truth, right? The truth is out there. If you remember the old X-Files TV show, you might be too young for that. Anyway, but there are lots of other alternatives to this, and we might call some of these pseudoscience. So in that process of going from theory through research to knowledge uncovering, fact generation, etc., we can commit some sins of research, things like overgeneralization. So when some moons from now, sometime from now, forward in the progress of your thesis work or dissertation work, you're going to write not just a results section, which presents the factual data you generate out of your analyses and summarize the data you collect out of the field or wherever you're doing that. Then you're going to get into a discussion section or discussion chapter. And one inescapably important chunk of that discussion, or even the conclusion section, but generally the discussion chapter, is this idea of generalization. So whatever you find for the forest areas or the fields or the watersheds or the wildlife species that you're working with, there's some sense that if we have a similar species in a similar habitat nearby to where you're doing this research, or similar-ish watersheds at the same latitude over the similar kinds of soil types and underlying geology and so forth, that the things, the principles that you distill, the insights that you build out of your data collection and analyses, we want to be able to transfer that to the other watershed, to the other species, to the other forest habitat, so that you can sort of bring wisdom and insight to anything beyond that one spot and that one time that you did your research. If we can't generalize your work and apply it outside of its own originating context, then it's very, very difficult to justify the value of the effort and the time and the money and the safety risks and all that you put into conducting that research, right? So we want this to go somewhere. We want it to do good things. We want to do a drug trial to try and see if there's a new way to treat some specific kind of cancer in these 100 people. And if it's therapeutically more effective than our previous best guess at how to treat that cancer, then let's apply that to millions of other people with that cancer. That's the process of generalization. Taking what we've learned and applying it in a new context. To the extent that the new context is similar to the old one, that's a very safe generalization. One problem we have with modern society and the absolute glut of information that is being generated these days, the number of publications that are being generated these days, is it's really hard particular field. You know, a couple of years ago, there was a fairly famous study that just looked at the number of medical research papers that are being published around the world. And if your 24/7, 365 job was to read those research articles, you'd still be falling behind. There's not now more being generated than a human can even keep up with. So we're using tools like AI to try and distill some of those into treatment algorithms decision trees, stuff like that. But we're still facing this sense of everybody's overworked, we're tired, and there's such a glut of information that the answer that you need is probably out there. One problem that can happen with this oversaturation of new knowledge is this temptation to overgeneralize. That is, if I do a study here on the Shawnee National Forest in Southern Illinois, say a forest economics impact study of, we have X number of hunters and they spend money to buy their permits and they spend money at the local coffee shop to tank up on goat juice before they go sit in a cold tree stand to hunt deer, and that money flows around Southern Illinois, typically changes hands on average up to 6 times before leaving the community. And so that's a good thing. For every dollar that hunters spend into the community, well, that's raising the community's coffers by $6 because it gets spent in the community multiple times, then it goes off to some bank or gets spent elsewhere at some gas station across the country, whatever. Okay. Generalization would be, okay, so that $6 insight, we're going to assume that applies across the entire United States for all kinds of hunters and fishermen, and not just national forests, but wilderness areas, wildlife refuges, and private hunting clubs. That's reaching a little bit too far with that insight to make that assumption. So overgeneralization is a mistake of convenience or a mistake of lack of resources to actually apply insights within a reasonable and safe scope. Okay, so that's overreach. Selective observation is kind of somebody has a bad experience with a particular company, and so they jump online on Reddit and they go, this company's total bullshit, without having any access to other people's experiences with that company. It's a sense of, I'm going to pay a lot of attention to this particular set of observations, and these data over here, other people's stories about the same company or whatever, they don't matter to me, or they make my job harder of figuring out my conclusion. So to the extent that you have data that don't answer or seem to fall in line with your initial deductive model, your theory, your hypothesis, don't throw those data away. Those are the most important data of your study. Okay? A lot of science, a lot of the best science happens not with, okay, we ran this study and everything we found completely confirms our theory. We totally nailed our hypothesis on the first go. We are awesome researchers. No, the good science happens when somebody goes, okay, 99% of our data totally fit this model. And the other 1%, they're way off over here, way away from the predicted point cluster. Why is that? That's weird. A ton of good science happens or starts with, that's weird. Okay? Because the leaps in science happen when you have this established theory that establishes the 99%, but then there's that 1% that breaks it. And so you go right to that 1% and you go, there's a reason why my theory, which is pretty good, it's 99% effective, it's failing consistently. These data are clustered over here, not where this theory says they should be. So we take that theory and we drop kick it, and we shatter it on the ground, and we pick up the broken pieces and we reassemble out of it a new improved theory that does address the 99% and the 1%. That's how we get from the Niels Bohr model of atoms are like pudding and electrons are like raisins stuck on the surface of that pudding, to the subatomic model of atoms are collections of protons, neutrons, and electrons, to the quantum physical model of subatomic particles protons, electrons, and neutrons are made of still smaller things, to string theory. Those subatomic particles, leptons, bosons, mesons, quarks, all that stuff, those are actually 11-dimensional vibrating strings, superstring theory. Because each of those models was pretty good, but failed to account for something. And so we go for the failed to account for part and get from a bread pudding model to vibrating strings in 11 dimensions. You and I experience 3.5 dimensions, right? X, Y, Z, and we can move forward in time. Backward. 3.5 dimensions, right? Physicists are now talking about 11 or more, and multiple universes superimposed upon each other. Really cool stuff, but we'll never get to the multiverse explanation with the bread pudding model, okay? So selective observation it's a comforting thing, right? Okay, these 99% of the data answer, they speak to my thesis's hypothesis. Okay, I'm good, across the finish line. We'll call those other data outliers, and we'll just kind of forget about them. 99% is pretty good. That's like an A+, right? In those grading systems, my thesis gets an A+. But the good work happens by not doing selective observation, from being brutally honest and saying, you know what, 1% of these data do not behave the way they're supposed to. So in the conclusion section for my suggestions for future research, somebody, maybe me or somebody else, look at that 1%. There's something going on there. I know it. All right? Cool. Premature closure is you're running some wildlife research and you collect your data, and you start collecting data April 1st, and you finish collecting data August 15th because the semester is about to start and you're going to be real busy with classes and so forth. So you come back in out of the field and so forth. And then you extrapolate forward from August 15th to the following year's April 1st and say, based on what we know from spring and summer, this is probably what this wildlife species is doing the rest of the year. You don't know that, right? There are major and important changes that happen in wildlife distributions and behaviors in parts of the year that you are just not capturing. Premature closure is also things like, okay, we're doing a spatial sample across a bunch of space. And our spatial sample across a heterogeneous set of ecosystems, we've got a whole bunch of valley sites, and for whatever reason, the spatial sample just doesn't cover any of our ridge lines in this area, and they're meaningfully different than the ecosystems down at the bottom of the slopes, down in those valleys. But we rolled the dice, and that's why our random sample happened, and even though I suspect there's probably something important about the differences between ridge lines and valley floors, it sounds like a lot of extra work in ridgeline thunderstorm habitat to collect that data. So we're just going to go with our simple random sample spatially and call it good. So premature closure can be in time, it can be in space, or it can be in the variable space of, for example, we're measuring these 15 things about a species, and we should probably measure these other 2 things, but we just don't have money for that, so we're just going to go with what we got. Okay. This is bad. This is very bad. This puts big blinders, introduces major, or can introduce major what are called systematic biases, forcing factors and variables or time or space that are influencing your data. But you can't see it. You can just see the effects of it, and it's very hard or impossible to control for those biases because you just don't know. So when reviewers are looking through your manuscripts and they see in your research design premature closure, they are within their rights, and they should, ethically speaking, reject that science as faulty for the reason of premature closure. So this is uncommon. Usually, we pay a lot of attention to this in the research design phase to make sure that we're not just collecting 6 months of data when we really need 12 months of data or something like that. But when it does happen, it's usually pretty obvious. Like one of the reviewers will come back with, what happened to all the wintertime data? Something like that. The halo effect is totally different from the previous three. The halo effect is positive or negative light or attention or opinion or energy that is imputed to a research study or to a researcher based on something adjacent that is regarded positively or negatively. All right, so halo effect. This has a little bit to do maybe with overgeneralization sometimes. So the halo effect among researchers would be so-and-so, let's say your advisor, they're star researcher in their particular field. And so people have seen their work, they've been really impressed with it in the past, and for whatever reason on one research project, your advisor just kind of coasts, rests on those laurels, doesn't do a great research project, but all of their previous work has been so influential and powerful and so forth that reviewers can, if it's not a blinded review, they can kind of give mistakes in that study a pass because, oh my gosh, Dr. So-and-so is an eminent leader in this field. There must be a reason why he did this sort of weird design that doesn't really check out. A good reviewer will catch that and be like, you know what, it doesn't matter who's doing the study. If there's something wrong with the study, I don't want to give it any bonus points for who's doing it, and I don't want to subtract any score for who's doing it either. Okay, so the halo effect can be positive or negative, and so forth. So the halo effect can also be on the content instead of on the researchers. So where streaming video and webcam technology has really improved over the last 20-25 years to the point that we can now do meetings in class, virtually or whatever. And that's a real benefit to society, especially during things like quarantining. What if that video streaming and conferencing and meeting with folks and stuff like that isn't so healthy when applied in a social media context? Experiencing people and a diminished sense of meaningful connection with them or diminished sense of relationship with them because it's through a tiny little 3.5-inch screen. Well, but isn't the ability to FaceTime with somebody all the way across the world, isn't that a good thing? Yeah, maybe it is. Maybe it's really harmful scaled out to social media where parasocial relationships, not real but real seeming relationships with social media influencers, for example, is relying on that halo effect and is doing some real harm to people's happiness and well-being. Okay, so these all happen every day, and we need to make sure that they're not happening within our domains as researchers. Let's go through a couple of key terms, just kind of definition stuff, and we'll probably end the class on most of these for today. So empirical, you've probably seen that term. All that means is it's data. Data is a plural word, so the data are gathered by sensory or cybernetically enhanced, that is using electronic sensors typically, or sometimes analog sensors. We're extending direct observation and turning that into a data stream. Okay, so this is used in a neutral or positive sense. Empirical work is research done through gathering data, analyzing the data, and putting on to everyone's awareness some kind of sense of what's the discussion, interpretation, usefulness of this research. Empirical is grounded in reality. You're going out there and you're measuring something. Not all research can be empirical because sometimes we're looking at things that can't be We are researching things that can't be looked at. So researchers working in the human dimensions of things, looking at love, right? So one of the central theses or central lines of the old movie Contact, the book Contact by Carl Sagan, was prove to me that you love your father. And Jodie Foster's character, the astronomer who makes contact with an alien species, says, well, I can't prove that. It's just, it's something I do. It's something I know. And that was very frustrating for her as a researcher not to be able to prove something. But she knew her love for her father was real, but she couldn't say that, you know, something that she does out of love for her father, that's not love, it's an action, right? Does that make sense? So some things cannot be captured empirically. Other things need to be captured empirically because it's an objective external reality, and so we characterize that through data collection. Question?
So would like an interpretation of an experience be empirical?
No. So logging data points about the experience itself as the experience is unfolding, that's empirical. Interpretation of, or subjective recall, or personal interpretation of it is one step removed from empirical. That's not bad, right? So in my line of research, a huge amount of the data I collect are people's registered impressions of a thing, but not data about the thing that they experienced. So beliefs, attitudes, opinions, motivations, and so forth. I can't observe those. They're in somebody's head. If I could record someone's thought patterns in sequence using fMRI or something like that and seeing through direct electrical activity how somebody was making a decision, that would be an empirical recording of that process. But instead, I'm doing what's called a proxy measure. I'm measuring someone's actions and reverse engineering out of their actions. Well, they must have had a motive or motivation to do that action. Some belief upstream of the motivation that doing that action would be a good thing, beneficial to them. And that's why they did it. So it's okay. In a negative sense, you might hear some people refer to a study as, oh, well, this is just empiricism. That is an over-reliance on objective instrumentation, streams of data, and stuff like that for something that necessarily involves something, any part of that mechanism or process or phenomenon that you're studying that cannot be resolved through data collection of an external, physically manifested part of the universe that you're studying. Okay? So the empirical approach is foundational to science. For certain kinds of research projects, only empirical data cannot be enough. Okay? So you'll hear folks say this needs to be more empirically grounded. You need to put in more data or collect different kinds of data that are just, nobody can disagree with that. It's just the measurement of temperature at your research site. You need those empirical data for a lot of field studies. And sometimes empirical is an oversimplification. It's a reductionist tendency to say, well, I can't know what people's thoughts, beliefs, attitudes, opinions, motivations are, so I'm just going to measure this stuff, when maybe for whatever reason the research question needs to be about those attitudes, beliefs, and so forth, right? We've had a lot of interesting and strange things happen with elections since 2016. That's a whole other degree. But it's important to capture empirical information about that, and very, very important to understand and investigate the non-empirical parts of the weirdness of American elections lately. Okay, cool. So that's kind of a big abstract sense of a really big, important facet of research. If you have any questions about the empirical, you can spend some more time on it. Data is a plural word. Datum is the singular. One single data point is a datum. Datum is also used as an established or fixed reference point. Okay, so a geographic datum is literally a thing cemented into the ground or epoxied onto a rock outcrop where it is very, very carefully surveyed down to essentially the centimeter and affixed to that spot and says, all right, we know this thing isn't going to move. We can measure everything else as a relative measurement as an offset from this established datum. Okay, so the equator is a datum for latitude. Prime meridian is a datum for longitude. It's a fixed arbitrary, but fixed reference point that everybody can agree on and say, all right, this is where 0 degrees is. Okay, cool. Please. Use data as a plural word. Please. If you're a linguistic descriptivist, you will be correct in noting that a lot of people use data as a singular. Look at this data is one example of that. Those people are wrong. Let's talk about, we've mentioned this briefly so far in talking about your thesis proposal, the difference between the term methodology versus methods. Okay, so methodology, as suggested by the structural morphology of the word, that is the morphemes, the single units of meaning, about the size of a syllable in English. So method is what you do. And logi comes from the Greek for word. Methodology is the word or study of methods, the philosophy of methods. Why did you choose the methods that you are choosing? And the why, or the answer to the why question has a lot to do with what's the context, what's the time and the space and the political or social culture in which you are even evaluating a particular research question as important or valid or not. It's all context. What is the ethical way, or what is an ethical way to study that research question or to try to answer it? And what assumptions are you having to either build in as a researcher or confront as a researcher and try to make them explicit so that you can incorporate those into what you actually end up doing, which is a lot more like a recipe. We used these things, these ingredients, these tools. We cooked the data, we analyzed it, and this is the delicious thing that we got out of, this delicious insight that we got out of this recipe of methods. Okay, so all I have to say, if you title your methods chapter methodology, no one cares, except for the crotchety old person on your committee that totally cares, is going to get super bent out of shape. And it's like, well, you're not telling me your methodology, you're telling me your methods. Okay, so if you get that person, just change the title of the chapter or put in a couple of paragraphs on why you are typically at the beginning of the methods section. Establish the context of your methods. Why am I choosing this method instead of that method? You can cite a couple of earlier influential studies that guided your thinking on that. Okay, not a problem, but we do want to understand there are people whose entire careers are rooted around thinking about why do we use this technique versus that technique when they both seem like they get us somewhere. They're looking at the ethics involved, the assumptions, the context, the limitations of one tool set versus another, versus the benefits or the costs or the risks. All of that stuff has to figure in, okay? But for a thesis or dissertation proposal, especially for a thesis proposal, part of why you're here in the first place is to pick up these methods, to skill up on this stuff so you can bring that out into the professional world. As a PhD student, typically you're focusing a little bit more on the methodology, the why, as well as the what and the how of the methods. Okay. We've got a couple of research paradigms that we're just going to be able to get started with today, and we'll have to come back to a little bit later. So we've got the positivist, the interpretive, the critical, and the feminist research paradigm. We don't have the masculinist paradigm because that's kind of all the others anyway, right? Something patriarchy. Okay. The positivist paradigm is what you and I are most familiar with in Western culture, Western cultures these days. So logical empiricism, I've seen that term before, at least the empirical part. Post-positivism, naturalism, these are all basically the same thing at different stages of the science, the conversation of science since about 1850. And the rise of modern research ideals. The positivist paradigm is the sense of, regardless of my hallucinations, my naivete, my ignorance on any particular phenomenon that exists in the observable universe, regardless of yours, regardless of anybody's, our ignorance about a thing doesn't change the thing. We go measure the thing empirically, and then we start building up a theory of what the thing is, how it works, mechanism or process or cycle. And with enough research, with enough correct data, we can pretty well nail the thing down, right? We know what lightning bolts are. We know how they get started. We don't think there's any sort of a spiritual, unobservable component to lightning bolts. They're just kind of a huge spark, right? And we know about how much electricity or charge transfer happens. We know the climatic conditions and the geologic conditions that give rise to specific lightning probability enriched areas. And once we sort of nail all that down, okay, there's not really much interesting to research about lightning bolts anymore. We've got the functional model. And some things lend themselves really well to the positive paradigm, right? So fluid modeling, for any of you who are working in forest hydrology, for example, flow modeling, the Navier-Stokes equation, the Bernoulli principle, stuff like that. Like, we know why airfoils work. Driving a plane forward through the fluid of the atmosphere produces lift. That's very, very, very well understood. There's not a whole lot of mystique or like sexy mystery around airfoils. Yeah, there's technological advancement on, you know, essentially paper and cloth wing designs, to swept wing designs, to delta wing designs, to flying wing designs, to ring wing canard designs, etc. But none of that changes our understanding of how airflow works, air pressure, air density, and so forth. Logical empiricism works pretty well. And so for the kind of person that likes to have things nailed down, understood, there is objective truth, and it's out there. Objective truth. This is the paradigm that most health research, thank God, works along, right? So we test drugs. We don't have faith in drug companies. Like we were talking about last week, the statistician's mantra is, in God we trust, all others bring data. And if you're Pfizer or Merck or Mariel or whatever, and you want to put a new vaccine into the world, you by gosh darn better have a whole bunch of really solid data. We don't care about how much you believe in your vaccine. It could just be snake oil. You have to prove it to us, right? So that's the positivist paradigm. We're positive about these things. We're sure about them. There's concrete reality, unaffected by our perception of it. We can characterize that stuff with data. We're good to go. Okay? There are lots of other ways of knowing. This is a really bad model for understanding parts of the human experience, but it sure does work for natural objective phenomena. Okay? Let's end it right there. I'm around for questions if you have them. And for Thursday's class, we don't have any further assignments that I'm aware of. If we do have any, I'll post them on the course website. Okay? Cool. Question?
Yes, so 2 questions. One, I'm looking at the graduate student announcement page, and it looks like the most recent event that's coming up that I can see is, or there, there's only 2 postings. One of them is from back in January, but this one is like a theater costume design thing.
Okay.
Would that count as one of our
things
to rate, I guess?
Heck yeah.
Yeah. Okay.
if it's science or research, it doesn't have to fall into the positivist paradigm. There's all these other things you could do, right?
Well, I don't even know if it's science or research. It looks like it's like a play. And I
Okay.
don't really know what, and it says MFA in theater for costume design. So am I critiquing their hemming and the colors of their
No,
garments? Like,
that's a good question. So this is content independent. That's a really good question. You are going, any of us is going to any of these, A, because it might be interesting, and it's really fun to live in a college town because there's always a million bizarre things happening all at once. It's just so cool. Anyway, for us within this class, though, the goal is very much to take a look at, understand, and start to critique for your own improvement. How is this person communicating well? So research in costume design can be with new kinds of fabric or materials. Vanta Black has been, it's the blackest black pigment. It's like disorientingly dark. You can't see anything painted in black, in Vanta Black. If there's another Vanta Black field behind it, it just disappears. It's wild. Anyway, so that set off a whole list of essentially art experiments that don't have anything to do with trying to characterize the objective natural world. It's we're playing around with cool paint, but that's still research, right? So how do they communicate it in a way that's effective? Do they talk about it? Do they show you the thing? Do they show you instead of telling you? Do they record a voiceover and take themselves out of the communication process in a live setting? Or are they standing and delivering behind a podium, white knuckling it because nobody likes public speaking and they're kind of nervous and they're just trying to get through it and okay, we're done, and so forth, right? So we're going to see, right, what's the cool project, but also what did this person do that worked really well? And maybe one or a couple of things that, you know, they could have done differently or that you would do differently if you were presenting a similar kind of project. So very quickly you'll see some folks that are very comfortable and fluid and natural up in front of a group of folks and they're fairly effective. Other folks are just trying to gut it out to the end and they'd rather be anywhere but there, but they got to present their work. We'll see some useful differences across some of these. So that's why we're doing a couple of these during the semester. Sound good? Okay. But it can be something like that. It doesn't have to be like a wildlife science thesis or whatever. It can be kind of anything that involves professional science communication or professional communication, really. Other questions?
I have kind of an unrelated question.
Fire away.
I just had a meeting with my advisor a little while ago, and it was kind of short, so I didn't get a chance to ask him, but I'm getting a poster ready for a conference.
Cool.
I need like an abstract turned in by a certain time. And how is that abstract like different from like a thesis abstract? Because I always heard the abstract's like the last thing you write.
Yep.
So turning an abstract in to get accepted to the conference.
Yep.
Is it a different abstract or the same abstract?
It's the same, typically it's shorter. Yeah, so to the extent, oh, your proposal is more done, right? So, ish, yeah. So typically the thesis abstract is going to be like 1-2 pages long, up to 750, 1,000 words, something like that. Often conference abstracts are as short as 150 words. That's like 3-4 sentences. So you get a little bit of space because they're having to review hundreds of abstracts and they just can't afford the brain power to do that many that fast and make a decision on them. So yeah, I would write your thesis abstract first, it's already written, and then, you know, edit like you're over caffeinated and get down to that word limit.
Like an abstract of abstract.
Yeah, kind of. That's about right. So yeah.
Have a good one.
All right. See you next time. See you Thursday.
I've got a question for you too. So I don't
Sure.
remember your policy about not coming to class, but I'm presenting at a conference Thursday, like all day.
Totally unexcused absence. Can't do it. Just kidding. No, that's totally fine.
Yeah.
That's
okay.
awesome. That's exciting. Are you
It's
presenting
fine
about your
if you're
thesis
thinking
or
about it.
previous project, or what are you doing?
So my project is an ongoing project, so I'm presenting kind of like old findings and
Yeah,
then
okay.
some new data, and then
Okay.
kind of like what we're planning on doing for the PhD student that's coming after
Awesome.
me. So yeah, I feel like I've got a lot to live up to, so I'm kind of nervous to present, but
That's
I
okay.
think it'll be a good experience to at least get some exposure to presenting.
Yeah, in most conferences, it's going to be a bunch of like professors and typically in our fields, practitioners as well, you know, guys and gals in the Forest Service, Park Service, whatever. And if they know you're a grad student, like there's allowances for that. If you're not perfectly polished, if you're just a couple of months into working on the project and you just got handed this like pile of data and this presentation sort of skeleton or whatever, and like, go, let everybody know. We all get it because all of us have been there before, and it's a little bit weird the first time. It's like, okay, so I wasn't even a graduate student when we collected this data, but let me show you what we did. Like we've all been there. It's okay. Generally, they have a pretty friendly audience, unless there's somebody who they don't know you from Adam, but if they have beef with your advisor, sometimes that person can try to rake you over the coals a little bit. So if somebody just starts grandstanding like that, hear them out. Usually the storm blows out, and if they get super wound up, if you don't rise to the bait and if you don't get super wound up, then usually that person starts getting like the side eye from everybody else in the room, like, really? You're going to be that asshole wasting everybody's time, you know, whatever your axe to grind is against your advisor, who's not even at the conference maybe. Yeah, just let them blow themselves out. It happens occasionally. I wouldn't worry about it, but if it does, you know, just rat it out. You can ask, so help me understand, what was the question in that statement, you know? Ask a question like that. And they're like, no, I'm angry. I wanted to be heard.
Yeah.
That's all it is. So that's cool. That's this Thursday?
Yes.
All right, so you guys are getting ready to ship out like now.
Yes, yeah, so I just had my poster hopefully printed off. I haven't checked back with the IT people, but.
Great.
Yeah, it's exciting, but yeah, so I think I'll be getting back at like 8 or 9 o'clock at night, so.
No worries.
And I think I'm just gonna be like in the conference all day, so I don't know if I can attend Zoom, but I'm assuming that's recording.
Yeah,
But
so here's the recording. It's got the.
Loaded later that day or later in the week maybe.
Yeah, usually it takes me a couple of days to finish out the process, but yeah.
Okay, awesome.
So no worries. Good luck,
Awesome.
or break a
Thanks.
leg, depending on your superstition. All right.
Appreciate it, thank you.
See you on Thursday.
Yeah, cheers.